To begin, the first thing I'd like to point out with this video is it would be helpful if you had a calculator with you, one that has log and natural log, which is, remember, natural log is LN buttons on it, to make sure that you're able to use the technology to solve these problems. So we're going to talk about change of base formula. If you look at your calculator, you should notice that the only button you have that involves log is log. Remember, log means base 10. So we can only use our calculator to help us out if we're in base 10, or since there's also an LN button if we're in base E. So we've already looked at how we can use changing back and forth between exponential and logarithmic form to help us to simplify many logarithmic equations. However, it's not true for all logarithmic equations. So when we cannot solve our logarithmic equation by changing to exponential form, we have another trick, which is called the change of base formula. It tells us that if we're given some log that we're unable to solve, if we can change it to either base 10 or base E, then we can use our calculator. The way to change base is to pick our base of choice, let's call it A, and we take log base A of whatever we were originally taking the log of, divided by log base A of our original base. So again, we are always going to choose A, either 10 or E, since that's what we have on our calculator. So looking at a couple examples here. On example 1, I have log base 6 of 4. So notice if I wanted to be able to figure out what this was, my first instinct might be to say that equals something, so how about I try changing to exponential form? But notice I don't know what 6 needs to be raised to in order to equal 4, so that doesn't work. So I need another method. Well, according to my change of base formula, I can pick my base. Let's say I pick base 10 and say log base 10. Remember, I don't have to write it if it's base 10 of 4 divided by log base 10 of 6. Then from here, I'm going to use my calculator to assist me. I'm going to go ahead and put log of 4 into my calculator divided by log 6. When I do, I'm going to remember to round to 3 decimals, and I get 0.774, or approximately. So therefore, my answer is approximately 0.774. If I look at example 2, again, my first instinct might be to say, oh, it equals something, so I'll ask 1/3 to the what equals 8. Well, I don't know of any way that I can change base 3 to get me to 8. I know I could bring that up. I could change 8 to base 2, but 3 and 2 aren't going to match, so I don't see a lot of progress happening with this form. So instead, I'll try to use my change of base. Well, change of base tells me I can pick my base. Let's say I pick E this time, since I picked 10 last time. Well, if I do log base E, I know writing log base E is the same thing as writing ln of 8, because according to my formula, I put the whatever I was taking the log of originally on, I continue to take the log of that on top, divided by log base E. I do have to choose the same base on top and bottom of 1/3. So now from here, again, I can put this right into my calculator. Doing that gives me about -1.893. Again, rounding to 3 decimal places. And there's my approximate answer, so I should say approximately. Finally, looking at the last example 3 here, this was supposed to say log base 15, not ln. Hopefully you recognize that that doesn't make sense since ln already has its own base. Again, nothing I can do with this, so I can either change to base 10 or base E. It does not matter. If I change to base 10, I would have log of 33 divided by log of 15. Again, from here I go to my calculator, and I get approximately 1.291 for my final answer. And that is the last example. The big thing is you just have to memorize this formula here. If you can memorize the formula, as you can see, it is fairly easy to use, especially since once you write the formula out, the majority of the work is done with the calculator for you.